So hello everyone, I welcome you to the TechToy 2020 hackathon organized by Startup Cell of NIT Arunachal Pradesh and sponsored by TechCube 3. I am Tejas M, second year B student pursuing computer science from Dr. Ambedkar Institute of Technology, Bangalore. So my topic for today is Arduino and infrared sensor. So the main objective of this presentation is to understand the working principle of infrared sensor and how to control two LEDs using infrared remote or any TV remote and their applications. So Arduino so before getting to live demonstration, let me explain some brief information on Arduino Uno and infrared sensors. So the Arduino Uno is an open source microcontroller board based on the microchip 80 mega 328P microcontroller and developed by Arduino company. So here you have the Arduino Uno board. You can see the picture. It has some components like USB plug, external power supply, and this is the main 80 mega 328P microcontroller. And you can see the pin details of it here. So these are some technical specifications of Arduino Uno. The microcontroller is the 80 mega 328P and the operating voltage of Arduino Uno is 5 volt. The recommended input voltage is 7 to 12 volt. The analog input pins, there are 6 pins, A0 to A5, and the digital input output pins, there are 14 pins, out of which 6 provide PWM output. DC current on the input output pins is limited to 40 milliampere, and DC current on 3.3 volt pin is 50 milliampere. The flash memory is 32 KB, and the 0.5 KB is used for bootloader. The frequency or the clock speed is 16 MHz, and inbuilt LED is on pin number 13. The reset button which resets the microcontroller, and the USB plug, we use the USB B type to connect it to the computer. So the software required is Arduino IDE, which you can download it from the link provided here. So this is the TSOP 1738 infrared receiver, and this is TSOP 1838 infrared receiver, and TSOP 1838 is just some improved version of TSOP 1738 infrared receiver. So TSOP 1738 is an infrared receiver with an amplifier that acts as a switch and converter within the circuit. The basic purpose of TSOP 1738 is to convert the infrared signals to electrical signals. Every infrared receiver has a specific frequency to operate. The TSOP 1738 operates at 38 kHz infrared frequency. In case of higher or lower frequency, it may act due to a current leakage or some other errors, but it won't fully operate. It uses silicon based technology which works at the micro level and very sensitive and efficient to its function. So in summary, TSOP may be smaller in size, but its usage with microcontrollers and microprocessors make it smart and secure. So the working principle of TSOP 1738 is as follows. Excuse me. When the infrared remote is pressed, it sends out infrared radiations. As you can see in the diagram, the TSOP 1738 detects the infrared, which is switching on and off at the rate of 38 kHz. So here you can see the signals, and the TSOP's output is active low, means its output will continue to remain high when there is no infrared radiation, and becomes low when it detects infrared radiation. So as to eliminate interference, the TSOP 1738 operates at a particular frequency so that other infrared radiations in the environment can't interfere except the modulated infrared of particular frequency. So here you have the remote control. It sends the infrared signal, and the IR receiver it receives the infrared signals and convert it to electrical signals or binary signals, which can be detected by microcontroller. So the components required are Arduino Uno breadboard, TSOP 1838 will be using a TSOP 1838 IO receiver, infrared remote, and two LEDs and jumper wires. So this is the circuit diagram. We should connect the above mentioned components as shown here. So the infrared sensor, I will take the infrared sensor. The first pin is the output pin, which I have connected it to the 10th pin, and the middle one is the ground pin. I will connect it to the ground in the power section, and the 5 volt pin I will be connecting it to the 5 volt. and here the cathode of two LEDs have connected to a common ground to the ground on the digital pin, and the anode of the LED 1 is connected to 11th pin, and anode of LED 2 has been connected to 12th pin. So now how to decode the infrared remote control signals using Arduino. So when any button of the infrared remote is pressed, the remote sends a code in form of train of encoded pulses using 38 kHz modulating frequency. These pulses are received by TSOP 1838 sensor and read by Arduino, and then Arduino decodes received train of pulse into a hexadecimal or a binary value, and in turn will display it on the serial monitor. So it is as described here in the image. So the requirements for this project is you need to have the infrared remote library. You can download it from this link, and you need to unzip it and place it in your Arduino libraries folder. So the flowchart and the program I will be explaining in the next coming live demonstration. So you can see that I have the required materials here. It is the Arduino Uno. You can see here the power pins and analog pins and the digital pins. So let me go with the connection. First let me take the IR receiver. It has 3 pins. The first pin is the output pin, the second one is ground pin, the last one is VCC pin. So let me connect the output pin to digital pin number 10. Now let me connect the VCC to 5V pin and the ground pin to ground. So I have connected the IR receiver. Now let me connect the LEDs. So I have the breadboard here. Let me connect the cathode of both LEDs using the jumper wire. So as you can see here, the jumper wire. So I have the cathodes. I will connect it to the digital ground pin. Now let me connect. So I will connect the ground to the digital pin, the ground pin on the digital pin. Now let me connect the node of the green LED, that is our LED 1. To the 11th pin on the digital. Now let me connect the anode of red LED, that is our LED 2, to the 12th pin. So we have finished with the connections. Now we move on to program. So we use the B-type USB. So let me go to Arduino IDE. So this is the Arduino Uno IDE. I have opened the remote control code. So if you go to tools and then go to get board info, you will see that Arduino Uno has been correctly working. Also you can see that here Arduino Uno is on communication port 10. So this is the program. The first line of the code is the contains the header file irremote.h, which is necessary for the program. Then here I have declared the pins. This is for the IR receiver pin, that is on digital pin. LED 1, that is green LED, I have declared it as 11. Then red LED, which is LED 2, I have declared as 12 pin. So this line IR receive, IR pin receives the IR signal. Then it decodes the result into a variable result. Then it has two parts, while two functions, setup and loop. So in this setup, I have initialized the LED pins as an output. LED1 and LED2 are the output pins. And here I have begin the serial communication between Arduino and the serial monitor. Now coming to the main part, which is the void loop function. Here I have used the if and the switch case statements. So inside if I have written IR received dot decode ampersand result, which decodes the IR signal. Then in the switch I have result dot value. So result dot value gives the infrared code. So this is the value for which we need to compare. So if I press the up arrow, this is the code for the up arrow, then it will turn the LED to low, that is off state, and it prints that you pressed up the button on the serial monitor, and then it will show the result value, that is to say this is the same thing, serial dot println result dot value in the decimal format, and then the LED1 will glow eye. If I press the down arrow button, then this part will be executed. So you can see then LED1 will be low and the LED2 will be high. If by default if I press any other button, it just prints the, you press the other button, then it will print the value of that button. And this after the switch statement, the loop it should continue, so I have used the resume function and then a small delay. So let me upload it, go to sketch and then upload. Here it shows the compiling sketch in the status. So it is uploading and you can see that LED flashes on the Arduino board. So it shows done uploading. Now I am gonna go to tools and go to serial monitor. So it shows enabling infrared enabled IR. So it has been showing these values because there may be some loose connections. So now if I press the up arrow button, you can see the green LED will on and it shows the code, the same code. Now if I press the down arrow, then red LED will glow on and it shows that you press down button. So if I press up arrow, green LED will turn on. If I press down arrow, red LED will turn on. So up arrow is green LED, down arrow is red LED. So this is how we can control two LEDs using TV remote and Arduino. So coming to the applications, you find the infrared sensor everywhere, and some of the applications are you can use it for home automation projects, home security systems, and fire detections, proximity sensor, because everyone have proximity sensors in the smartphones today, and distance measurement and obstacle detection, etc. And coming to the applications in toys, infrared sensors are used in helicopter toys as shown in the picture, and infrared remote control toys the remote control spider which uses infrared, and UFO flying ball toys for kids, and obstacle avoiding robots, etc. So finally I conclude that in this presentation we have understood the working principle of infrared sensors and how to control two LEDs using the TV remote or any other infrared remote using IR sensor and their applications. So thank you.